Hello, welcome to the detail upstairs. This is the typical plan detail upstairs. Stairs has a few important things to be followed when you design a stairs. Number one is the stairs should be enclosed with the reinforced concrete shear wall. This is a solid shear wall up to the maximum thickness of 10 inches. You can have 8 inches as well, depending on the height of your building, and this is for the 10-story building that I designed stairs. The width of the stairs is 3 feet and 8 inches. The space between these two handrails is 6 inches, and that's the and the second important safety for stairs is the extension of the handrails. This handle should extend 12 inches from the last or the first thread right here. Okay, it's extended 12 inches at least. All the handrails should extend 12 inches all around. And number 3 is the door, the access door to the stairs. This door should be fire rated. The fire rating for this door is up to the maximum 3 hours fire rating. And the landing right here, this is the landing. The landing, when you turn the stairs, when you turn to other direction, this landing here should be extended. It's supposed to be right here. It should always be extended up to 1 thread, the size of the thread. Do not start the riser from here, right here, in line with the other riser. No, you can't fall down when you turn here quickly. Your feet, one of your foot there should end up in the riser, so you're gonna fall down. Chances are you're gonna fall down when you turn quickly over there. So therefore, this part of the landing, when you switch direction, either in this direction or that direction, it should be extended up to the size of 1 thread. So the minimum space of the landing is 3 feet and 10 inches. So therefore, the other side, the other half of the landing is 4 feet and 9 inches. The access door for the stairs should be equipped with the automatic closer. When you open it, it closes automatically for fire safety reason. The stairs is designed to accommodate the total height of floor-to-floor height for this building, and the floor-to-floor height of the building is 9 feet and 8 inches. So we're gonna have to, I will show you the calculation of the risers, how to get the risers. I included the elevator because elevator also is like a stairs. It is mandatory to be elevator should be enclosed with the shear wall. This is shear wall for the elevator. This is a freight elevator. The freight elevator and the passenger elevator is just, they have the same features. If this is your floor finish, a basement or a ground floor, the bottom part of the elevator should go down. There's some mechanical components in there, and under the elevator floor there's a lot of components there that responsible to run the elevator, and therefore you have to dig it like elevator pit. The elevator pit is 4 feet and 6 inches. So whether it is the basement or ground floor, you have to dig deep down 4 feet and 6 inches. And there's a ladder there. This is a steel ladder. The size of this ladder is 1 foot and 1 foot, 1 horizontal and 1 foot vertical. And also this ladder is extended above the finished floor up to 4 feet. Alright, that's the freight elevator. And now let's go to the calculation of the risers. Here's the calculation of risers. We have 5 steps to follow. Number 1, if the floor-to-floor height of the building is expressed in feet and inches, convert the balls into inches. And number 2, you have to choose your most comfortable riser from 4 inches to the maximum of 8 inches. And then number 3, divide the floor-to-floor height in inches by your set riser, which is in inches as well. You will get the number of risers. Number 4, if your calculation gives you an acceptable number of risers, you can adjust the height of your riser as long as you don't go over the maximum, which is 8 inches. 8 inches is very stiff. And you have to do trial and error and then retry again until you get the right number of risers. Okay, let's do some trial and error here. The floor-to-floor height is 9 feet and 8 inches. And here I'm gonna try first trial. You gotta go first trial, trial and error. So the first trial is 7 inches for the riser. The height of one riser is 7 inches. So therefore, you have to convert this height to inches. So 9 times 12, there are 12 inches in 1 foot. 9 times 12 equals 108 plus 8 inches equals total of 116 inches. Now let's solve for the number of risers. The number of risers is equal to the height in inches divided by height of one riser, which is in inches as well. In this case, I use 7 inches. So therefore, to get the number of risers, you have to divide 116 inches divided by 7 is equal to 16.57 risers. So from this calculation, we know that we can fit 16 risers for the total floor-to-floor height of 9 feet and 8 inches. But there is a 0.57 that looks like another riser, like half a riser at least. So we don't know the exact riser to fit this floor-to-floor height. Therefore, the number of risers for the height of 116 inches is 16 risers. We know that we can fit 16 risers there. And yeah, we can, let's go for it. 16 risers. So to find the exact height of one riser for 16 risers, let's form an equation here. Okay, let unknown riser height equals to x. So we don't know, this is the unknown. Put that riser unknown riser as equal to x. So unknown riser equal to x. If you multiply this unknown riser to the number of risers, it should be equal to the height, the floor-to-floor height of the building. Okay, that we're gonna install the stairs, and that height is 116. So we multiply the unknown riser by 16, it should be equal to 116. So to do that is to form an equation: 16 riser times the unknown riser, height of one riser is equal to 116 inches, and that's the equation 1. Alright, now we have an equation. Now from this equation, you manipulate this equation to solve for x. We have to divide this 16 goes down under 116, so 116 now divided by 16. We get the value of x is 7.25 inches each riser. That's one riser. So x now is equal to 7.25. 0.25 is like 1/4 of an inch. It's equal to one riser. Now substitute the value of okay, now we found the exact. Okay, we're solving for the exact. We let the unknown exact riser as to x, and then we form an equation like this one here, and then we solve for x, which is the one riser. Now to make sure that the riser is correct, you have to substitute the value of x, which is the riser, to equation 1. You have substituted there. So substituting x in equation 1 to check our riser or answer. 16 times 7.25 equals 116. If you multiply the known riser now that we solve by 16, that gives you 116 is equal to 116. Therefore, the height of the riser is correct. Alright, so we have the height of the riser. 7 and 1/4 of an inch. Okay, there we go. And then we lead it out here on the stair plan. The total number of risers for the whole height, for the entire height of floor-to-floor height of the building is 16 risers, as we calculated. So therefore, 16 divided by 2, there are 2 sections of stairs. Okay, and therefore each section has 8 risers. That's why it's in here. 8 risers at 7.25 of an inch. And when you have 8 risers, automatically the tread should be 8 risers minus 1 equals 7. It's always minus 1. Minus 1 from the riser and equal to the tread. The tread is pretty much pre-calculated. 10 is a typical tread size for the building. Every building should have these stairs here. So therefore we have 8 risers at 7.25 of an inch. Each section of the stairs. Total that is 16 as we calculated. And the tread is 10 inches. If you want to know the total distance of a tread, you just add this up. So you know where exactly is the tread. And the as I said, the minimum landing, this landing here is 3 feet and 10 inches, and the other landing here with extension, that's 4 feet and 9 inches. Alright, now there's the elevator. So we have that. You have that here, everything details here. This is going up, and that dust line there is going down. So So elevator fit. This is the plan. The freight. This is the freight elevator plan. The the opening of the freight elevator also is supposed to be enclosed with. It is mandatory to be enclosed. Any elevators enclosed with a shear wall, and the thickness of the reinforced concrete shear wall is 10 inches. As I said before, you can also have 8 inches depending on the height of the building and your local building code. Because this is building, you gotta go through building code as well. And the total opening of the space for the elevator, the freight elevator, is 9 feet and 8 inches. And the elevator itself, the distance all around from the face of the shear wall is 8 inches all around. And the edge to edge distance of the wall to wall distance, outside wall and outside wall of the elevator is 8 feet and 4 inches, and the length is up to here. This is 10. This is 10 feet. All right, and there's another 10 inches here. The concrete hollow blocks there, and this is 8 inches thick. But the to close the gap in between here, so there's concrete hollow blocks right here for the elevator door. The door for this freight elevator, it doesn't slide on the side. One goes up, opens up, and one goes down, up and down, the opening direction of this freight elevator door. And so here's the plan, and when you cut that section there, you cut this section here, you're looking at it, and you see the steel ladder there 4 feet above the floor. This is the basement of ground floor. You have to you have to go down as an elevator pit right here for the bottom of the elevator to go down. All right, and there's some mechanical motor mechanism in there under the elevator that runs the elevator. Actually, this is the elevator hoist way, and so yeah, so that's the elevator and stairs. The details of the elevator, the freight elevator and the passenger elevator, basically the details are the same. And now we have the details of the stairs, the reinforcement and the dimensions of stairs. So here's the stairs. The stairs is actually a slab. It's an inclined slab. This is a slab. You put an imaginary line right here. This is a slab. This thickness of the slab is measured from here up to the bottom here. And the slab, the stair slab is 6 inches thick. When you design stairs, you will approximately end up 5.5 to 6 inches or 7. 7 is so thick, so I design is 6 inches, and the reinforcement will carry the loads anyways. Here's the bottom bars. Bottom bars and the top bars. Top bars is smaller than the bottom bar. Top is 10 and the bottom is 15. And the distance in between, when you lay this out, is 6 inches in between. The clear distance, this is center to center actually, 6 inches, whereas the top bar is 12, so twice that. There's more on the bottom bar because this is the tension bar. This is actually the tension reinforcement. This is the reinforcement that actually carry the loads when the stairs is loaded. The stair will bend like this, so this is in tension, and the top is in compression. That's the concrete will take care of the compression by itself without even this. Just to put it together, that's why we have to have that top bars there as well. This is a stairs and you need to be safe. Alright, so the top bars and bottom bars and top bars, they're not the same. The top is smaller than the bottom one. And now here's the this is the temperature and shrinkage reinforcement. The function of the temperature and shrinkage reinforcement is to prevent the concrete from cracking. So when this is a beam, this is the stirrups of the beam. So, but since this is a stairs, we lead it out flat and 90 degrees in angle with respect to the bottom and top bars. There's no the shrinkage reinforcement is on the bottom of the bottom bar. It's on top of the bottom bar. Okay, there's no shrinkage reinforcement there on top. Instead, the stairs has one bar in each nosing. The shrinkage reinforcement bar is 10 millimeter, and it has a center to center distance of 12 inches, and each nosing of the riser has one 10 millimeter bar. Alright, and then here's the joint between the landing and these stairs. You have to provide these two bars here. This is the most important bars. This is a 15 millimeter bar. It's supposed to be this is not a shrinkage. This is not a shrinkage and temperature bar. This is like a dowel. There's 1 inch, one for the landing and one for the stairs. And the size of this is 15 millimeter. And in the landing portion of the stairs, the bottom bar is only 10 millimeter. Okay, because this is the landing and this is the main stairs. So the reinforcement here is a smaller 10 millimeter at 6 inches. This one here, this bar has 180 degrees hook. Okay, all around these bars here, the dowel, which is 15 millimeter. So it goes all the way through the wall where this landing is framed from. Alright, and it goes around and hook 180 degrees, and on the top side of the landing there's a 10 millimeter bar as well. It's like the temperature bar right here, same as that one, but that is the temperature bar on top. It's 10 millimeter at 8 inches apart. I just draw 3 here, but it's all the way to the top there. And also on the bottom there, this is 10 millimeter, and this is more. This is like 6 inches apart. And the same as the bottom bar here, this one here, but this is 10 millimeter. Because there's so many reinforcement here. There's in the landing section, this is the landing. You have to you have to install a square dowel enclosing all the bars. Okay, this one here is like a square dowels there, enclosing all these bars at the top and the bottom. And pay attention to the hook there, the development length of these bottom bars, and the development length also is 180 degrees for the stairs portion. This is the connection in between the landing and the stairs. And the top bar for the stairs, there is no cut off for this bar. This bar goes all the way to, it bends here 6 inches, and it bends horizontal parallel to the plane of the landing. Okay, the line here, see the nuts there? That is for the prefabrication of the precast concrete stairs when it is fabricated outside of the site. So we have to pour the concrete in this shape here with the nuts right here, and that distance there is 6 inches. When this is fabricated outside, this landing gonna wait for the precast concrete to arrive and install it right here. But if this is monolithic construction, monolithic means the concrete is poured together at one time. They are poured together at the same time, so this line here should be ignored when this is in a monolithic construction. But for the fabrication purposes, we lay out the line here. We have that distance there, 6 inches, and up to the nosing from here as well is 1 foot and 6 inches. So there we go. That's the details of typical stair detail as well. And now the simple details for the precast concrete stairs. This distance here below is C. There's 3 distances here, A, B, and C. This is the A, and this is the B. That's 6 inches. That's just 1.5 feet there. And this is the riser. And there's no value there because you have to calculate the actual and the exact riser for the stairs. So these 3 distances should be coordinated with the shop where you fabricate the precast concrete, because that's the most important dimension for the stairs to go. So here's what I'm saying here, the notch here, that's for the landing, for the precast concrete stairs to be installed. And this bar here, without the precast concrete, this bar is protruding outside and waiting for the stairs to be in place. The precast concrete stairs has a plate there where this thing goes and welded there. This reinforcement here, this is the top bar of the landing. It goes to the precast concrete and then welded it over there. And after welding, you can put cement on top of it to erase the gap. You have to cut that precast concrete and provide a steel plate where to weld this reinforcement from the waiting portion of the landing. Alright, that's how they connect this stairs. Alright, that's a simple details for the precast concrete. Alright, that's it. That's for the stairs, and that's the end of the video. And I hope you like it, and don't forget to subscribe. subscribe, and thanks for watching. Bye bye.